Hey everyone, welcome back. Today I'm here to show you how to combine the power of the X-Plane flight simulator with the PX4 Autopilot flight stack, giving new life into your software-in-the-loop simulations. This project has been and of course is one of my own favorites because we're diving into something I've been dreaming of ever since I started working with PX4, using PX4 software-in-the-loop within the X-Plane flight simulator. It's something I always hoped someone would implement and release, but here we are, doing it myself. With this tool, you can design any drone, fly it anywhere in the world, and do pretty much anything you want in a virtual world, even in a VR headset and even multiplayer mode, over your own house and X-Plane world. Watch this video till the end to discover how it works, its limitation, and of course a live demo of it in action. Let's talk about why X-Plane is such a great choice for software in the loop. Well, maybe not best choice for all applications, but let's find out in which application it stands out. First up, X-Plane's advanced flight dynamics are based on blade element theory, which gives you a realistic initial flight behavior without knowing much of your drones or doing any sort of modeling or CFD analysis before that. This is perfect for initial design steps of many drones, especially air taxis and heavy eVTOLs. Then there is the ultra-realistic global environment. You can get detailed trains, cities, atmospheric effects like wind, gust, rain, any sort of precipitation, and many more, improving the experience whether you are a virtual pilot, passenger, or part of a ground crew. You can actually feel flying in the environment instead of using simulated environment in JMapSim or Gazebo. Now about the customization. X-Plane's Plane Maker allows you to easily design your own drones. Very useful for drone developers, researchers, or even students. Using X-Plane's World Editor, you can build your customized environment and start flying there. Or just use one of many high-quality world scenarios available out there. Using SDK, you can create plugins and model your drone systems and subsystems, such as electrical subsystem. Plus, there is a VR support, which adds an immersive layer to your simulations, letting you see and control everything from a pilot's perspective, or even passenger, or you say from whose perspective you want to experience. The plugin ecosystem in X-Plane is also another advantage. There are tons of plugins out there to enhance the simulator's functionality for almost any application. From an educational point of view, X-Plane had been my best friend back in the days when I was a flight dynamics and control student. It's best tool for simulating navigation and control algorithm, which is great for both students and instructors. Imagine combining it with PX4 Flight Controller. Just assume students play with PID gains or EKF gains or other parameters and can see the effect on the drone or aircraft that they had just designed in their aircraft design course in real time. Lastly, obviously, X-Plane provides a safe environment to simulate various scenarios without the risk of real-world testing and cuts, making it ideal for validating drone operations. Let's now look at some current limitation of the PX4 X-Plane plugin. As I said, it's not the best choice for our application. First, the EKF or Extended Kalman Filter Estimator requires maintaining a high frame per second, especially in the scenarios involving high acceleration maneuvers. Then X-Plane is primarily designed for larger aircraft, which means it's not ideal for very small drones. However, this still has a very acceptable and good results. Agile and acrobatic drones are another area where X-Plane might face limitation. Your control and estimator loops are limited to the simulator's frame per second. But on the other hand, X-Plane is perfect for simulating heavy eVTOL air taxis, just like the one Austin is showing in the picture, Elia 250. As of now, in November 2023, the plugin primarily supports quadcopters. I'm planning to add support for the configuration like fixed wings and VTOL soon, so stay tuned. Alright, let's touch on how our PX4 X-Plane plugin actually functions without getting too deep into the programming. Essentially, it's a communication bridge. The simulator feeds sensors like gyro, accelerometer, GPS, and environment data to the PX4 flight stack on TCP using Mablink protocol, which then PX4 sends back motor and actuator control signals to the simulator, again using Mablink on TCP port. This loop happens in real time using PX4 X-Plane Plugin that you should install into your X-Plane. Basically, it's the only thing you need to install other than the regular PX4 developer tools. Now I don't want to overload you with all these technical details here, but for those who are interested, the full description and technical documentation are available on my GitHub repository's README page and within the PX4 documentation, so feel free to check those out if you are curious. And of course, any help and contribution is more than welcome. Okay, it's the show time. Enough talking about the plugin, let's actually see it in action. I'm going to walk you through a step-by-step tutorial where you will see how the PX4 X-Plane plugin works. Let's follow along with the tutorial to learn more about how this all comes together. First step is to get to this GitHub repository homepage. Link is in the description below. There are very good documentation about technical concepts and Mablink communication in this page, and if you're a developer, you can go ahead and use these steps as a developer to clone the project, get the submodules, and build it for yourself. Otherwise, if you're a normal user, click on this step-by-step instruction. You can find an easy-to-follow instruction from 0 to 100 that help you build this project for yourself. First step obviously is to download X-Plane 11 or 12 for your operating system. Demo version would also work, the only limitation is that you need to close X-Plane and open it again every 15 minutes. I recommend go ahead and buy the X-Plane at about $60 US. Next step is to download and install a quadcopter airframe. If you already designed a quadcopter or you have already one in your X-Plane, that would work, but I recommend using this quadcopter air taxi. Although it looks like it has 8 motor in X8 configuration, but basically it's a quadcopter in the flight mode. It has 4 motors in X-Plane. Download the file, extract it, and we need to install it in our X-Plane directory. Navigate to your X-Plane 11 or X-Plane 12 in aircraft folders, paste the aircraft folder here, Quadcopter Pilot, and that's it. Now you have installed this airframe inside your X-Plane. Next step is to download Qgroundcontrol. It's very basic steps. You might already have it installed right now. Download it for your operating system and install it. Next step is to navigate to the release pages of PX4 X-Plane plugin. Right now, the current version is version 1.00 beta. Download this PX4 X-Plane Win64 binary files. The binaries for Linux and macOS would be released in near future. Download this zip file and extract it in anywhere you can access to it. Open the folder. You might find a PX4 X-Plane plugin folder here. There is a folder inside it called 64 and a bunch of binary and config files. Copy this PX4 X-Plane folder to your plugins in your X-Plane. I recommend install it to the drone that you're gonna use. So you navigate to your X-Plane aircrafts and the quadcopter piloted that you have just installed. In the plugins folder, paste the PX4 X-Plane folder here. If you want to install this plugin globally for all the aircrafts that you have in X-Plane, you can copy it to the resources folder and plugins folder, but I recommend to install it only on the drones that you're gonna use in software in the loop. That's it. Now you have everything ready. Next step is deal with the PX4 build environment. The good news for Mac and Linux user is that you need no extra steps here. But for Windows user, you need to do a very simple short step here. You need to install WSL, which is basically a Linux inside the Windows. If you don't know what is WSL or Windows Subsystem for Linux, go ahead and watch these 2 short YouTube tutorials about the concepts of WSL and connecting WSL and PX4. These are very basic short steps and concepts. You can open Microsoft stores and search for WSL and install WSL on Ubuntu 22. I'm not going to cover the specific instruction and command because it's just changing over the time a lot. So basically it's becoming easier and easier to install WSL in Windows 11 and Windows 10. Once you have installed WSL, You can access it from your PowerShell or command line. Use WSL-help to see all the commands about WSL. For example, you can list all the containers or all the Linux distribution that you have installed right now. In our case, I only have Ubuntu 22, and this is the only subsystem for Linux that I have right now. You can go ahead and install any distribution you like, maybe Ubuntu 20 or Ubuntu 22 or Kali Linux with WSL-install and specifying the distribution name. And if you just want to do this project and you don't need any different version, just go ahead and type WSL-install and it will automatically by default install Ubuntu 22 for you. And once installed, you can access it by just typing WSL. And if you have other versions, you need to specify the distribution name to open up. In this case, that we have only one WSL here, the only thing that we need is to type WSL. And here we are. Now we are inside a Linux within our Windows. An important step is that make sure you always cd to the home directory of the Linux. Always type this cd, this tilde sign, and now you are inside the Linux. You can confirm it by typing, for example, who am I, and it will ask you, tell you the username that you have created with your Linux distribution. Now we have a Linux inside our Windows, and basically now we are a Linux user. Next step is to clone the PX4 Autopilot recursively to our system. Just copy and paste this command. Depends on your internet connection. It can take about 1 minute up to 20 minutes. It's gonna download a few hundred megabytes, and once completed, you will see this PX4 Autopilot folder in your system. Go ahead and cd to this PX4-autopilot with cd command, and you can confirm with ls command that everything is installed for you. If you are Ubuntu user, a ready-to-use script, shell script file is available that just by running this script, everything will happen for you and everything will be configured. Although we are in Windows 11 now, remember we are Ubuntu users right now, so we can use this command. And this command can take a few minutes, depends on your system. And once finished, you need to restart your WSL system. We type we type exit, and then we type WSL-shutdown. And once it's shut it down, we're gonna restart it again with WSL command. And now we are good to go. Next step is to get the IP of our system. We need to open a new terminal. Remember, this terminal should be inside your Windows, not inside your Linux. Make sure it is your Windows system. You're gonna type ipconfig, and you're gonna look for the item that says Ethernet adapter for WSL, which is the Hyper-V firewall. You're gonna copy this IP. Basically, this is the IP of your Windows system that is accessible from the Linux subsystem. So WSL, Ubuntu, and Windows can talk to each other within using this IP. If you don't understand these things and you don't understand these IP concepts, no matter, just follow whatever I tell you. Just copy this command, export px4_sim_hostname and the IP that you have copied from your Windows. Basically, you're gonna tell your PX4 software in the loop environment that, hey, send all the data to the Windows. We're gonna run our simulator, which is X-Plane, inside the Windows. And that's it. Next step is just use the make PX4_software in the loop, just like the time you were using JMapSim, Gazebo, AirSim, and any other simulator. Remember, this step might have some troubles for you. You might find some errors. There's some good documentation about it. You can use make PX4 software in the loop clean and this clean to just rebuild a whole repository from scratch. And if you still have some problem, go ahead and watch my YouTube tutorials about PX4 software in the loop and WSL to get a more in-depth tutorial. All you need to do is to type make PX4_software in the loop none_iris. And it can take a few minutes for the first time on your system, maybe even 10 to 15 minutes depending on your system. And once it runs, it says it says the sim host name is the host IP that we set for our Windows, and it says we're waiting for simulator to accept connection on TCP port 4560, and make sure this port is not blocked by your firewall. Now the PX4 stubs have been finished, and now we're gonna head to Qgroundcontrol. We're gonna configure the Qgroundcontrol to connect to the PX4. In this case, we're gonna tell it to listen to the port 18570, which is a default port for WSL. You can create a connection, name it whatever you want. The type would be UDP and the port would be 18570. And the server address should be your WSL IP. What is your WSL IP? You need to navigate again to the command line of your WSL. You can open a new tab and just type WSL. Again, if you don't know about this IP stuffs and networking, don't worry, just follow whatever I told you. It's the basic simple concepts. Just copy this IP. This IP is your Linux WSL version IP. So Qgroundcontrol should know from which source it's gonna get the Mavlink source. And we just click connect. Now QGC is on standby mode and waiting for Mavlink packets to arrive. Only one step is remained, and that is connecting our X-Plane. So in this step, we're gonna open our X-Plane 12 or 11 and load our environment. We're gonna run a new flight in whatever place that we want. But we need to do some consideration. Depends on your system configuration and your graphic cards and your CPU. You might need to change some of your graphic settings. We need to have a very high frame per second. Preferably about 100 frames per second I recommend. But anything about 40 would do the same. You can enable the frame per second overlay and just monitor what is your frame per second. The more frame you have, the better EKF estimator and better flight quality you have. And if you have a low frame per second, make sure you increase the flight model calculation to a maximum so you have a better flight model calculation. Let's load our quadcopter air taxi in Mehrabad Airport runway 11. If it's your first time in X-Plane, it might take a little bit while to just load the environment for you. Okay, here we are. We are on the runway and only one step is remaining. And this is to connect our plugin, connect our quadcopter to the PX4 software in the loop environment. Right now, X-Plane is operating by itself. It's not getting command from PX, so you can fly your drone manually, but we want to connect it to PX4. In that case, you need to go to the plugins menu and find the PX4 X-Plane plugin, PX4 X-Plane, and simply click on connect to SITL or connect to software in the loop. Once you click on it, look what's happened. Software in the loop immediately connects,
position
and
flight
the
mode.
QGC detects the drone and showing our position and status. Now our motors have stopped because they are getting the command from PX4 and we are disarmed. And now we are ready to fly. Now PX4 thinks it is connected to a physical real drone, and X-Plane is trying to is communicating with PX4 software in the loop. But we need to do an extra step here. Since the motor convention and motor setting and some of the PIDs is a little bit different in the PX4 software in the loop and X-Plane, we need to change some things here. For example, in actuator, you can see it's not actually correct. The motor diagrams, the motor direction, and these things are different between Playmaker, Quadcopter, and the PX4. We need to change it. For that, I have provided you with a param file that you can download from the release page, and it's already available for you in the plugins folder as well. You need to download this Quadcopter PX4 parameter and load it to your QGC. In that case, go to your parameters, click on tools and load from file, and navigate to the plugin folder that you have downloaded from the GitHub. Inside PX4 X plugin 64, and just select this Quadcopter params. These are all the parameters that is gonna be overwritten, and click OK, and now you can see actuators have changed and the conventions and ordering and direction does match with the quadcopter setting. Depends if you are using a custom airframe, you need to change this actuator settings by yourself. If you want to manually fly, make sure you calibrate your joysticks. If you have a joystick and you want to manually fly, make sure you have calibrated your joystick before the flight. Okay, let's set this drone to its maiden flight. Just like any normal drone or software in the loop environment, you can click on the takeoff in QGC and the drone would take off to its predefined altitude, just as you can see in the picture. By looking at the wheel side, you can see that we have a significant crosswind from the left, but the drone is keeping its position in position flight mode. We can command it to any sort of commands such as go to commands, and we can see the different perspective, different view, different angles of the drones while it's flying. We can also witness the drone movements from the tower view, from Merhaba Tower, using different controls that we have in X-Plane. Here it is, we have the view from the tower and it's flying at a speed of 5 meters per second, and now it's reached the destination. It stops and we can command it to land. Let's command it to land at current position. The advantage of this sort of simulation from maybe Gazebo or JMapSim is that you are really flying in that environment. Look at the map and look at the environment. We are actually on the runway. Actually the river, the buildings, everything are really located in the environment. That's the advantage of this flight model.
Disarmed.
Just like any sort of drones, you can fly in stabilize mode, echo mode. Let's test position flight mode. And now I'm gonna manually fly this drone and manually fly it. Let's arm it with the joystick. You can see my joystick position with the red dot in the left side of the Garmin panel. The red dot shows my joystick position. And now we are in position flight mode and holding position. I can manually fly it in position mode and just wander around and maybe violating the Merhaba airspace restriction. On the right side, in the right hand, you can see the animation of the joystick position that I'm in. That's my input to the drone. Let's fly this drone and maybe park it in the apron. Meanwhile, you have all sort of telemetry login just like a real-world aircraft. For example, here are velocity controller, set points and PID gains, or rate controllers or attitude controllers. These are very good educational tools for students, for flight controller students, and even for control analysis of the drones. Okay, here we are. We landed manually in position flight mode. But this is not all of it. We can do an autonomous mission. Let's disconnect this session. We disconnect from software in the loop. We can hit Control C to stop software in the loop as well. Let's change our position to maybe one of the parking positions in Merhaba airports. One of the parkings near the towers. And then we're gonna plan a real autonomous mission and let our drone to fly the mission. Here we are. We just again run PX4 software in the loop non_iris. Again from plugin menus, we hit select connect to SITL. QGC regains the connection and updates our position. And software in the loop also is mentioning that we are ready for takeoff. This time we are not gonna do a manual flying. let's do a plan mission. This is our view from the Merhaba Tower. Let's open the flight plan menu. We assign the takeoff waypoint to 10 meters altitude. I hope we won't collide with anything in the airport. Set it to 10 meters. We can change the yaw or airspeeds. Let's go a little bit to the east or maybe to the west so we'll be closer to the tower. We set the waypoints to the apron near the tower. With the default speed of 5 meters per second, maybe another waypoint at this taxiway in runway 29 left. It should be Bravo 2 or Bravo 3. And then set our return to launch as the last waypoint. So it will climb to 30 meters and return to home position. Let's start the mission from here. We can trigger the mission from here or just click on the action and start mission. And voila, here
Mission
it is.
flight mode.
The drone is gonna
Armed.
do an autonomous mission for us and return at this exact same position. It will take off and climb to 10 meters as you can see. And here's the first leg of the flight. It's going to the waypoint number 2. We can enjoy the view by violating the airspace and the area around Merhaba Airport. We can see the aircraft, taxiways, ground crew operations. We can view this view as a passenger. You can share this view with a VR headset to a passenger. This is something for another video. I'm gonna upload another video about this soon. Let's view it from the tower again. Here it is. And let's enjoy this view. Okay, here we are, and our drone is almost landing at the exact point that it started its mission. One more thing that I want to mention before ending this video is that we can use the log that we have generated from this flight. The ulog file that is generated from this flight can be acted as a real
Mission
flight.
flight mode.
Let's see how. You need to get access to the ulog file of this flight. You can go to the Ubuntu file structures, open your home directory, find the PX4 Autopilot folder, go to the Build folder, PX4 Software in the Loop default. If I'm not mistaken, going to the rootfs log folder, and here we are. This is the log file that we have generated today. Let's select the flight that we just did. Let's copy it and paste it to our desktop. And now we're gonna use the PX4 log review tool to analyze our log. Just navigate to the review.px4.io. Here you can give it a description and upload the ulog file that we have just copied to our desktop, which is this one, 6:41 AM. The description would be something like X-Plane, PX4, maybe Quadcopter SITL. and just add an email, for example, to give you a link. This way you have a log generated for you that is actually showing the paths that you have taken exactly. For those of you that you have done a lots of software in the loop inside the JMaps, you know that the terrain and position information is just an arbitrary, but here it is real. And you have feedbacks from all the sensors within the X-Plane. You can use this for educational purposes, tuning and improving your drones. And furthermore, you can use the 3D view or PID analysis. In PID analysis, you can see how your PID gains have tuned. It's a perfect tool for educational tools for control engineers. Here it is. It's not just showing a perfect result because all this flight we were in an autonomous mission. For PID tuning, you better fly in manual or stabilized or acro flight mode and do some sort of maneuvers and some sort of abrupt inputs. Okay, that's it. I hope you have enjoyed this video. For one more time, I want to emphasize this is the beta version 1.00. Definitely it has a lots of problems and it's gonna be fixed over the time, and I'm gonna add support for the fixed things, eVTOLs and other configuration as well. So if you see any bugs or you have any recommendation, make sure you open a section in the issue page, in the GitHub page, or just simply put it in the YouTube comments section below. And make sure you like the video and subscribe the video to not miss the next videos on this subject. In the next video, I might create the demo with the VR headset and how you can use this plugin for training, for pilot training, for passenger enjoying the scenery. And that's it. I'm not going to spoil it anymore. Stay tuned for the next video. Thanks for watching. Good day.